Hi dear students. Let's see this question that came in KVPY 2018 essay part 1 physics paper. Basically this question is on the topic of rainbow. We have to select the correct statement about rainbow. Now the first statement is that we can see a rainbow in the western sky in the late afternoon. Actually this is wrong because if you will try to think about the formation of the rainbow, then you will always see that it will be on the opposite side of the sun. Because for example, we all know that rainbow is formed when the sunlight enters inside the water droplets suspended in the atmosphere, and then it reflects inside the water droplets, and then when it comes out goes in our eyes, and that's how a rainbow, like we are able to see the rainbow. So for example, if this is the water droplet and the sunlight is coming from this side, so it will get refracted over here, get reflected over here, and again it will get refracted and it will go into the eyes of observer. So these are the eyes of the observer. So you can see if sun is on this side, this is our sun, then we will be able to see the rainbow this side. Okay, but if the sun is on the east side, then we will be able to see the rainbow on the west side. So in the late afternoon, we can say that sun is on the west side, so we will be able to see the rainbow on the east side somewhere. So this statement is wrong. Double rainbow has red on inside and violet on the outside. Actually, this is the correct statement. The double rainbow, of course, has the violet, on the outside and the red on the inside. Double rainbow is formed when there are two reflections inside the water droplet. In a single rainbow, which is called primary rainbow, there is a single reflection that happens inside the water droplet. Acha, one more thing, guys. This is not total internal reflection. In many textbooks, also, or in many sources, you will find that they have said that it is a total internal reflection, but this is not a total internal reflection. This is just a normal reflection. Whenever a light ray is incident on any particular surface or any media which is separate, any boundary which is separating two media, then there's a partial reflection and partial refraction. So this actually is a normal reflection. This is not total internal reflection. See, total internal reflection is not possible in this case. If this angle I, for this angle I, this angle R exists. See, if a ray has been able to enter this water droplet, so since this, that means we have got a value of I and R. I and R are existent, right? Now this angle will also be R because this is radius and this is also radius. So if this is R, then we will again get the value of I. I will be possible, and hence ray will be able to come out. So refraction is always possible. If you understood what I said, then remember that this is not total internal reflection. This is just a partial reflection. So as I was saying, I have taken two diagrams. You can see this is the normal rainbow. So here violet is inside and red is outside, and this is the secondary rainbow. This is the second or double rainbow. Okay, this is a very faint image, but you will be able to see this is a primary rainbow. So here violet is inside and red is outside. Here red is inside and violet is outside, because this happens because of the twice reflections happens twice. So we get inverted where images formed of the primary rainbow. So we get the colors get inverted. So this is the correct statement. A rainbow has an arc shaped since the earth is round. This is wrong. Rainbow has a, let's understand why does a rainbow has an arc shape. In reality, if you say, suppose the light is coming, I'll draw one more figure. Suppose this is water droplet. Suppose light is coming like this. Okay, so it will get reflected, and again it will get refracted. Here refraction, reflection, and refraction. Now this is the, we can say this was the ray which was going inside the water droplet, and this ray comes out of the water droplet. Now for the rainbow to be visible, the angle between these two rays should be somewhere around 40 to 42 degrees, because intensities for other angles, the angle between these two rays can be different. If you change the change the ray at, like change the point at which this ray is incident, then you will get different angles at which ray is coming out. So angle between these two rays can change, can have different values. So when the angle between these two rays becomes 42 degree, 40 to 42 degree, from 40 to 42, 40 for violet and 42 for red basically, then that's where the intensity becomes maximum. Okay, this has a mathematical proof for that. I'm not going into mathematical proof, but as of now, just remember this, that this for this value from 40 to 42 degree, the intensity becomes maximum. So that's when we see the colors. For other values, we are not able to see the colors. So now think, suppose the ray is coming like this. Okay, so it when it comes out at around 40 to 45 degrees and enters our eyes, that's where we will see the colors. Okay, now how should we arrange the water droplets so that each water droplet sends the ray at 42 degree? Think. Okay, so for that I have taken a code to explain. Now imagine, see, sun is very far away from us, so it will send parallel light rays to this. So suppose I have arranged water droplet along the circumference of the cone, like this, like this, like this, like this, like this, like this. So this is a cone, and I have arranged the water droplet like this. So first ray strikes this, and let us say this ray is for, this angle is 42. Okay, so this will come along this, like this ray will enter the eye of the observer. Again, which the ray which strikes this droplet will again go along the surface of the cone. So if you think in three dimensions, this angle will also be 42 degree. If you see, this is the circumference of the cone. So any ray that is coming like this, any ray that is coming like this is going along the surface of the cone. The ray that comes along this will go along the surface of the cone. Similarly, the ray which comes along this will also move along the surface of the cone. So all the rays will be coming back at 42 degrees with respect to the incident ray. So we can say that if we arrange the water droplets along the circle or circular arc, then that's where we will be able to see the colors. So that is why the rainbow is of circular shaped. Okay, it's not this. It has got nothing to do with Earth is round. This is wrong. Rainbow on the moon is violet. Rainbows on the moon is not possible because there's no atmosphere, so we'll not have any water droplets. So option B is right. I hope you would have understood. That's it. Thank you.